Okay, let us look at this question for alkenes. It says two reactions of an alkene are shown below. And we see our alkene B, because of its double bond, is reacting with hydrogen gas in the presence of nickel to give you that compound A. We also see it reacting to give you compound C. So let us look at the question. The question says, state the name of A and write an equation for its complete combustion. Explain why the incomplete combustion of A is dangerous. So first thing we need to look at is for compound A, we need to look at what it's coming from. It's coming from this 4-carbon molecule, which has a double bond between these two carbons. So obviously, if we're going to be adding hydrogen, remember you learned in class that the hydrogen will add across the double bond here and here. One hydrogen atom here, one hydrogen atom here. And you're going to get this molecule. So based on what we have, we're not going to have any branching. So it's just going to be a straight chain molecule that has 4 carbon atoms. We know that that will be an alkane. 4 carbon atoms, that will be butane. All right. We also want to find out what the equation will look like for the complete combustion. So here we have our starting material, C4H10, combustion in the presence of oxygen gas, and if you look at each of the elements, the carbon will combine with the oxygen to give you CO2, and the hydrogen will combine with the oxygen to give you water. I normally start balancing the carbons first. That's easiest. 4 carbons on this side, none on this side. So this is going to give me 4 carbons here. Hydrogen is next. I always leave my oxygen until last to make my life much easier. This is 10 hydrogens. We have only 2 on this side, so we're going to put a 5 here. Now we have oxygen until the last. Oxygen is in 2 atoms, 2 molecules on this side. So it's going to be a little bit difficult to balance. This is why we leave it until the last. So we have 4 2s 8 plus 5. That's 13 oxygens. So we need 13 on this side. So then we put a 13 over 2 or 6.5 here. And now we have our balanced chemical equation. The last part of this question says, explain why the incomplete combustion of A is dangerous. There's several things you can put, but the more appropriate one would be the presence of carbon monoxide, which can be produced. So C carbon monoxide may be produced. That's one thing you could write. You could also further expand on it. Remember that carbon monoxide is able to combine with hemoglobin in the blood, and that can be very toxic. Something else you could have written as well is that the production of soot, that could also be a problem that could arise due to incomplete combustion. Note carefully, the question specifically stated incomplete combustion. So the next question we're going to look at is how to distinguish between A and B. If you recall, A was our alkane, had no functional group, while B had a double bond for our alkene. So we need a reagent that will be able to test for the presence of this unsaturation in compound B. And the first thing that should jump out at you is that we can use bromine water. Bromine/water to test for the presence of the unsaturation. You may also use bromine in carbon tetrachloride, some organic solvent, but the more widely used reagent is bromine water, we call it. You are also asked to state the result in each case. Please read your question very carefully. This is very important. In order to get the full 3 marks, you need to state clearly what happens to each of the compounds in the test. So for compound A, which was an alkane, no double bonds, you would write that there is no effect. While for compound B, which had our double bond or our unsaturated center, you would make a note that it decolorizes your bromine water. Or you could also say that your bromine water changed from brown or reddish brown to colorless. All right, okay. Now, the last part of this question says we're to write an equation to show the conversion of B into C. And if you recall, this was what B looked like. It was our alkene here, and we're going to convert it to C. So one thing you should realize if you start to count up your hydrogens, you'll realize that we now have, here we had 3 and 3, 6 and 2, 8. Now we have 9 hydrogens, meaning that 1 hydrogen was added, and we've introduced this bromine atom, which indicates that H and Br were added, indicating that some addition was done across the double bond. So we're going to quickly then copy compound B into our booklet. And then we need to then state that HBr was added. And then remember, when you add across the double bond, the bond becomes saturated, the carbons become saturated, and the hydrogen will add to one of the carbons, Br would add to the other. It's a symmetrical molecule, so here it doesn't really matter which carbon the hydrogen is added to. So I'm going to just go ahead, write back all the things that didn't change. And then I'm going to add, I'll show it in a different color just to clarify. Hydrogen was added to 1, bromine was added, and you realize the double bond disappears. If you realize you started with 2 molecules, you end up with 1. You've gone from an unsaturated molecule to a saturated molecule. So the question says, state the type of reaction that occurs. And this, as you've learned before, is what we call an addition reaction. And so this is a structure of C, this is a structure of B, and we've converted B into C via an addition reaction.